Okay, let's keep going. And let's do 3.2, independent and mutually exclusive events. So independent and mutually exclusive events don't mean the same thing. Independent events, we can test if two events are independent if the following are true. So the probability of A given B, if that equals the probability of A, and then if the probability of B given A equals the probability of B, and then the probability of A and B equals the probability of A and B. So if the following are true, that's how you know if they're independent. So you just want to test them. We did this in the last section, so they're not that difficult. Two events A and B are independent if the knowledge that one occurs doesn't affect the chance of the other occurring. For example, the outcome of two rolls of a fair dice are independent events. The outcome of the first roll doesn't change the probability of the outcome of the second roll. To show two events are independent, you must show one of the above conditions. If two events are not independent, that means they're dependent, which means they depend on one another. So replacement. Sampling can be done with replacement or without replacement. So replacement means each member of the population is replaced after being picked. Then that member has the possibility of being chosen more than once. When sampling is done with replacement, the events are considered to be independent, meaning that the result of the first pick won't change the probability of the second pick. So that's like if I was going to have, I'm going to give away 5 prizes. And I draw my first winner and they win a prize. But instead of putting that winner to the side, I put their name right back into the pot and they have a chance of getting chosen again. That means with replacement. So without replacement means when sampling is done without replacement, each member of a population may be chosen only once. In that case, the probabilities for the second pick are affected by the results of the first pick. The events are considered to be independent and not independent. They're considered to be dependent and not independent. If it is not known whether A and B are independent or dependent, assume they are dependent until you can show otherwise. So without replacement means, so I'm having a drawing and I have 5 prizes again. So I pick my first winner and I take their name and I set it to the side. So now I only have people left in the pot for the prizes. Then if I pick the next winner and put it to the side, my sample gets smaller and smaller with every name I take and I put out. All right, so let's look at this. So A and B are mutually exclusive events if they cannot occur at the same time. That means A and B do not share any outcome and A and B are 0. So let's look at this example. So my sample size is 1 through 10. Event A is 1 through 5. B is 4 through 8. And C is 7 and 9. So I know A and B share 4 and 5. So that means they cannot be mutually exclusive. And I can do the probability, which is 2 over 10, and that is an equal 0. But A and C don't have any numbers in common. So A and C equals 0. Therefore, A and C is mutually exclusive. Remember again, mutually exclusive means they have no events that occur at the same time. So here's an example. Let event G taken in math class. The probability that you're taking a math class is 0.6. Let H taken a science class. So the probability of H is 0.5. Then G and H taken a math class and a science class. So all I do is I multiply those together and I get 0.3. So are G and H independent? How would you know? Well, remember that rule that you have to show if one of the following is true. So the probability of G given H, where the probability equals G, the probability of H given G, where the probability H, and the probability of G and H, where the probability of G times the probability of H. So let's look at it. Are G and H independent? If G and H are independent, you have to show one of the following. So let's see. The probability of G given H, if I do all the math, I get 0.6. The probability of H given G, if I do that, I get 0.5. So are the probability of G and H equal to the probability of G and the probability of H? So if I do the math, yes, it's true. So they are independent since one of more is true.